looking at the sprite animations today, one thing you will notice is there is a data folder. We haven't looked at it before. Processing gets much happier if you take your extra assets you're working with, such as images, and you dump them into a folder and call it data. That makes processing happy. Technically, if you don't put them in the data folder and they're in the same folder as your sketch file, it will still work, but it's a good practice to do that. But don't name this folder something else because you want to call it images or sprites, or just call it data. That's what processing will be looking for. Inside the data folder, you could have additional folders, so you could organize things by folder. That certainly is a possibility. And then that means when you're referencing how to find the image, it would be then showing that path. So you'd specify the folder, then the file name. If we look at the files here, you will notice that they are all named the same with sequential numbering. 0001 through 0023. So it's 4 numbers as part of it. A word, 4 numbers, a dot, and a PNG or file type extension. So that's the naming scheme that went into this. Now, I'm not a complete masochist, so I didn't name these all by hand myself and rename all of my files, saving them out one at a time, but instead I took advantage of Flash's ability to export a sequence of images and number them in a sequential manner. So then that works out quite nicely for us. Looking over at Flash, here is the file. Now, if we look at it, I'm in scene 1. Here's my artwork, but we don't see the timeline because this object is a movie clip. If I double click on it, I get into the movie clip. My movie clip has a name of face, and when I look at this, I will notice that then inside the timeline we can see how the animation occurs. So it closes and reopens, and then it just perpetually will keep looping. So this particular animation, now when you build a movie clip animation, you can have as many extra additional parts, so it can be very complex. Can have dozens of layers, transparency, movie clips inside movie clips. All of the animation things that you've ever done before you can do into this. And then to get it out, we go to our library. And ball is a failed element that my computer was freaking out. But face is the element here, and I can hit play. We can see the eyeball squishes. To get my image out, what I can do is right-click on it when I'm in my library. So I'm not going up under File and Exporting, but I'm right-clicking in my library and choosing to export a PNG sequence. So I can now export the series of images from here, and it will ask me, okay, where do I want to put them? So I'm going to actually then re-export a copy on the desktop so we can see how it works. And when we go to export, so I chose PNG sequence, so it's exporting it as that. That is the preferred format when we are doing this because PNG graphics work well in all of the web browsers, desktop and mobile. So when you're building assets for these kinds of environments, it really is preferred. And if you're building for native applications for mobile devices, tablets, and phones, PNGs are considered the standard. They are the best to work with, and they also support transparency where JPEGs do not. So they would be the image format we want to use. Otherwise, we would end up with something with a big solid white background around it, and that would look kind of crappy because we want our eyeball to be cut out and to be able to show on any colored background. So when I hit save, it now gives me an option here, and it tells me how many frames it's going to be, and we notice how the 23 corresponds to the 23 frames in my timeline. The height and width match the size of my artwork, and the resolution, well, we're exporting at 72, that works, and the 32. If we don't want transparency, I would use 8 or 24, but 32 is what we need if we want transparency. And then I hit export, and it thinks for a moment. And I can get back to the Finder. And if I look on the desktop, I will see there's my Faces folder, and there are my 23 files. So that is the first method that we will be looking at and integrating in coding. So this is what's used in Sprite Animation File 1. Sprite Animation 2 uses a different technique that we will take a look at, where the image is now exported as a single graphic file. In this case, I did it just as a single line, but we could also do it as a sheet where it would have rows and multiple rows and fewer columns instead of 23 columns. It's just another way of doing it, and we can certainly take a look at that. But right now, I thought I would keep it simple and just to look at these two techniques. Advantage of doing it this way, where the graphic is now being exported as a single graphic, is if you envision that an end user is, say, loading your file on a mobile device. Well, to load this graphic file into my program, I have to load one file. And this particular file is 2.324 bytes in size. Now, if we go to Sprite Animation number 1, we will notice that this is 1,091 bytes. But there's 23 of them, because every file has a minimum byte footprint that it takes up. So every file takes up a minimum amount of disk space on top of the actual data that's contained in the file. So because of that, this is now taking 23,000 bytes versus the 2,000 bytes of the single image. So this would be, hang on, no. So 23,000 versus 2,000. So that's not a lot until you think about, well, what if I had 50 different sprites in my project, and a bunch of backgrounds, and some audio, and I keep throwing ands on there, and pretty soon that little bit gets to be pretty significant that the end user has to download a whole lot more data. Nobody gets to have unlimited data plans on their devices anymore, so that can make your users grumpy. 1. 2, every time I have to ask for a asset from the server, I have to make a request to the web server and say, hey, would you send me that document? And then it has to get its act together and go, oh, you mean this thing? Sure, okay, yeah, I'll get around to it. I'll put it in the queue. Then it sends it to you. And then you have to go, oh, thanks for sending it. Now I'm going to deal with what you sent me. So we could do that one time or 23 times. So if we're loading 23 graphics, we take a file size hit, but we also now take a loading hit of, now I have to make so many kind of calls to the server. Even though every file is super tiny, that repeatedly, it's like someone coming to your door, knocking on the door, hi. What do you want? I just want to say hi. You go sit back on the couch and then knock, knock, knock. They're back at the door, hi. Over 23 times versus once. Now, fortunately, your mobile device won't get grumpy because it's a computer and they don't get grumpy about that, but it will slow down performance. So we want to limit the number of times we actually ask the server to give us something. So even if a file we're asking for is bigger than a bunch of small ones, that process of asking for and then having the transmission and then receiving that file can sometimes take more time than the actual transmission of the data. So we prefer to limit the number of calls we have to make. So in larger projects, it's not uncommon to actually put all of the graphics. So if you had 100 different characters in your game with 20 frames each, you would put all of that into one large graphic and just download one large file to the end user. Yes, you would wait longer for that one file, but you wouldn't be doing all this repeated server calls, and you would get better performance out of it. So that is the preferred way. And when you bundle multiple pieces of artwork onto a single graphic, that's referred to as creating a texture atlas for your project. So you can just file that little term away, texture atlas. So if you're ever having to look up how do I do this and where's some code for it, loading a texture atlas is what you would be searching for. Spreadsheet refers to when we're doing a single character or single objects animation. Multiple ones contained on a single document means we're loading a texture atlas. Those are our two kind of vocabulary terms for this afternoon. So PNG sequence is one way. The other way for sprite animation too is we can use generate sprite sheet. Just again, remember we have to put it into a movie clip and then we're exporting it from the library. We're not using the main timeline and exporting from file export. We could export image and then we can export it as a sequence here, but it doesn't work as well. It's much easier to build your animations, build your pieces, and then you just export it from the library. That is the preferred way. And this method, or this technology, Adobe built into it, starting with CS5. They added part of this in as an add-on that you could go, like a plugin you could add to it, because they licensed the sprite sheet generator from Grant Skinner, who produced it for Adobe. He made an open source tool, and then Adobe said, hey, could we just put that in Flash? So then it showed up in, I think it was CS5, for sure CS6, now also in CC. So if we choose to export as a sprite sheet, we can see it look like this, where we see the sequence of frames, and right now it's building it into a gridded sequence. Right now for today, to keep it simple, we're going to do one long horizontal versus rows and columns, because that requires a little bit more, 2 more lines of code than what we have, but I just want to go there this afternoon. So the key thing to remember about this is my sprite is 32 pixels tall, and then it is 23 times 32 pixels wide, which was approximately 736 pixels. So I can now change this to 736. When I do that, there's my 23 frames. So it shows me this preview of what the sprite sheet's going to look like. The checker boxes here indicates it will be transparent around the eyeball. So it's now just stacking each frame of the animation, one next to the next, next to the next, so on and so forth. So generating my sprite sheet. Enter in my dimensions, browse to where it's going to save it. So in this case, I will just put it on the desktop so we can see it, because I already have the finished ones that I do need. I can change the name now if I want, saves it out, hit export. And here on the desktop, there's the sprite. And here were the 23 individuals. So that is the method for getting the sprite sheet or getting the image sequence out of Flash. But if you want to build a simple character animation, walking, running, falling, jumping, exploding, you can do that quite readily in Flash very easily. Make your 10, 20, 30, 50 frames worth of animation, export it out as a sheet or an image sequence, and then now we can take advantage of that when we work on it in processing. One thing that's important on the image sequence is notice the numbering scheme. We have a word, then we have a collection of 4 numbers, so our sprites can be sequential. This would allow you to have 9,999 sprites. It's highly unlikely that you would build an image sequence that would be 9,999 images in a row, because that would be a colossal pain to load. It'd be taxing on the system. It wouldn't be a good plan. So the 4 numbers generally should serve in 99.99999% of the cases that you would ever need to use this. All right, so now moving into the code side of it, when we look at that inside sprite animation, this will now dump my little sprite on screen, and he blinks. He doesn't move because his X and Y are unchanging. So he's the unchanging eye. He just keeps blinking at us. Now, looking at it, I've created a sprite class, sprite updates, sprite displays. The way that the sprite works is that inside the sprite object, I have an array of images. That array is then, I have taken each one of the images that we are looking at and loaded them into memory using my load image command. And once they are loaded into memory, then I'm able to specify which image I want to see at any given time. Now we'll talk a little bit more about this in just a moment. So I have an array of images. Then I have a couple variables, x, y, width, height. That should be fairly stock or standard now as you work on projects for visual objects. And then I have my frames. This would be my total number of frames. So if you wanted to call it something else, you could do that. And then I have my current frame. That will represent which image in my sequence I'm currently looking at. Now, one thing, whenever you're working with images, you never want to load image or the same image more than one time. Because if you do, that's going to, over time, eat up your memory. So I've seen students where inside their draw function, they say, load an image, and then they say, you know, show me that image. Well, every time I say load image, I now used up a little bit more of my precious memory. And then a little bit more, and a little bit more. And after we run at 30 or 60 frames per second, I've now reloaded that same image 30 or 60 times per second. And if my project runs for 10 seconds or 20 seconds or a minute, that tiny little chunk of memory that I ate up actually grows to a fairly substantial amount until the whole program goes belly up. So creating or loading assets is a very expensive operation. You want to do that one time, and you do that inside your setups. So this Sprite Constructor function here, which is part of my Sprite class, executes right here. So I say, hey, I'm making a new sprite, and I'm going to set aside memory for a sprite object. Then I make my new sprite, and when I run that line, my line 7 we see here, it's at that moment in time that this chunk of lines executes. So that's when it loads it. So it only happens inside my setup. It only happens one time. So because of that, I'm not going to kill my memory by reloading the same object over and over and over and over and over and over again. Now, just so that we can get a sense of what's going on with it, I'm going, instead of doing it as an image sequence, I'll even do it, I'll kind of minimize that for a little bit and just load a single image. So I made my variable, then I'll just load the first frame. Oh, that's too many zeros. It's 3 zeros and a 1. 4 numbers long. So now I've loaded it. Now under display, I can just simply say image, and then we specify where I want it to be. And I'll just put it at 300, 200, and minimize that for now. So remembering that loading an image is just, I load it, so I have my variable, populate the variable, and then I use the image command to show it on screen. That's what it takes to show an image. So we've looked at that a couple times. It's in chapter 15 in the book. So that loads that image there. But doing an image sequence says, hey, I want to load all of those images. Well, if we're loading a whole bunch of the same thing, it makes sense to keep them in an array. And that's what our images array was for. So I have my images array up here. Then I need to populate images. So I say images is, and then it's the same way we make any array, but instead of being filled with numbers or strings or anything else, I'm dumping my images into it. And I know that it's going to be, the quantity of images will be how many frames long my animation is. And we know my animation is 23 frames long. As we can see, it's 23. 1, 2, 23. So that's where that number comes from. Then I use a for loop to fill up my array. Now I don't have to use a for loop. I could just manually do it, but if I'm doing the same thing over and over and over, a for loop is nice. Now we do have something we haven't looked at here, and it's this nf I plus 1 comma 4, which looks all mean and scary, mathy, programmy. You know, it's hateful language. It just makes you uncomfortable, but it's not so bad. NF stands for number format. That says I want to format this number so that it has 4 digits. And then we specify what number we want to format. In this case, it's I plus 1. Now the reason we're using I plus 1 is the first time through my loop, I has a value of 0. So I'm trying to construct that string, face 0001.png, face 0001.png. So I'm trying to construct it dynamically. Well, if I just said face I.png, well, that's not going to work. So I has a value of 0. This loop stops running when I has a value of 22. But if I look at my files, I see that I'm looking for a value of 1 through 23, not 0 through 22. Because Flash, when it numbers the frames, it starts counting at 1. It doesn't start with 0. It's just what it does. But we're able, because it's just offset by 1, we can offset our line by 1. So the first time through, I plus 1 comma 4 formatted as a number gives me a value of 0001. That's 4 numbers long, and it takes I, which was 0, and adds 1 to it. So the next time through, where I is 1, gives me a value of 0002. And it keeps repeating until it's done. Now when we get into the double digits, we get 0010 for 10. And the good part about that is otherwise we would have to figure out how do we code it for the first 9 where we want 000 and a number, and then the subsequent ones where we want 2 zeros and 2 numbers. That would really suck. We could use 2 for loops, we could put an if statement and all kinds of annoying things. But because processing has this built-in number formatting method, it makes our life really easy. So if you're at a loss for like, okay, now how do I do that again? What's it called? Just think number format, NF, and then you can go wander yourself onto processing's website. You can even just type in NF, and here it is in the reference. Now we can see where it comes up and it says, okay, NF. It shows us what it's going to do. It's going to take that number, and so if we look at C, which had the value of 90, out to 3 characters, it'd be 090. All right, so that's what NF does. It's a pretty useful, handy little kind of, it's a utility method that allows us to represent our number nicely. So when in doubt, use the help file. I use them every single time I sit down to code. I will be in the help file looking up at least the syntax for one element, if not more. That's normal. keep a reference book handy, keep the help file handy, use resources. I've never met a programmer who works purely off of memory. Everybody uses resources looking for things. So we keep looping through until the final time where we get 0, 0, 2, 3, and then that gives us our final image. They're all inside our array. Now comes the fun part. So now we use the image command, and then we say, I want to see what image? Well, I want to see the image that's contained at my current frame. Current frame starts out at 0, and then we position it at our X and Y location. Now, if we had a changing X and Y, then we could see some really cool things happen here, and we could see it move. Let me just see, I do have an update there, so yeah, why not? I'm going to just put that in for fun. We'll do X plus plus. It's just going to wander horizontally across the screen. When it goes off screen, by then I hopefully will be done talking, and then we'll close the sketch so I won't have to worry. I didn't put a return, so it's not bouncing back. So then now that's going to show it to us. So now we should see one fixed eyeball and one eyeball that's slowly wandering its way across the screen. It's not blinking yet, though. It's the unblinking eye of Sauron, so we're going to have to take care of it and make it blink so it's a little bit more interesting to look at. And that's where we now modify current frame. Now, what we could do with current frame is we could modify it so it goes up. Each time it goes up, then we will get to see a new frame. So when we look at that, now I'll run this. And it ran for a little while until I hit the end, and then it gave me an error message. And my error message is array index out of bounds. Remembering that there are 23 images or faces in my images array, I never made current frame go back down to 0. So it went 0, 1, 2, 3, up to 22. And then as soon as it hit 23, well, there's nothing there, so then it failed. And that's what this if statement takes care of. The if statement says, hey, if the current frame is equal to my total number of frames, 23, set it back to 0. So now when I watch it, we'll see the blinking eye of Sauron's polar cousin. That's why it's blue, because he lived in the Arctic. And then it moves across. A different way to go about these 4 lines of code is to use one line of code. Current frame is equal to current frame plus 1. Do the modulus math operation. So we're dividing by the number of frames. So when current frame is 0, 0 divided by, that becomes current frame plus 1. So that becomes 1 modulus frames. That gives me now a remainder of 1. So as I work my way through with current frame, it now goes 0, 1, 2, 3, 4, 5, 6, all the way up to 22. And then current frame plus 1 when it's 22 becomes 23. 23 divided by frames, which is 23, has 0 remainder, which makes current frame back to 0. So it's a little math magic line. It's like the coolest for people who like really elegant optimal code where you do it in the fewest lines possible and still can somewhat read it as a human being. It's just, it's magic. It's cool. I like it. So that's what we end up doing. But if you don't like that modulus math operation because it makes your head hurt, you leave that line commented out. You leave the current, and then you use current frame plus plus and the if statement. Totally valid. That's no performance difference. There's no, you're not going to find anyone who would chastise you for doing it that way, but they would say, there's a one-line version of that, and you'll say, yeah, I know. And that's okay. They are doing the same thing. It says when current frame is equal to total frames, we reset it back down to 0. So they perform the same item. There's generally, 19 different ways to get to the same finish line. Some are more efficient, some are more elegant, but if you get to the finish line, you're doing better than 80% of the population, because they generally won't. So that's what you want to work towards. Sprite animation 2, when we look at Sprite animation 2, there's a little bit of difference going on here inside this. We're actually loading our image inside the setup. Because we only have to load one image, it makes sense just to load that image and be done with it inside our main setup instead of inside the Sprite class. Now, I left what was in the old Sprite class, I left that there so we could see that not that much has changed. I only added a little bit of newness. So I load the image inside my main setup instead of inside the Sprite. And instead of using the image command, what we're doing is we're copying the image information from an image, but we're capturing a portion of it. So we're saying, I only want to see a chunk of this at any one given time. And we do that, we look at that chunk by figuring out our source X, source Y, and now because I'm representing it, its width and height is the same as my frame's width and height, I get to recycle those. And then this is the X and Y of where I want to draw this current image on screen. But the way that copy is working, we can go look in the reference file. It's as easy as anywhere to make sense out of it. And it's an image pixel option. So when you have an image in memory, then you can copy a portion of that image. And when we look at the syntax for it, we're looking at this syntax that I'm attempting to highlight right there, where we have the source of the image that we're looking at, what image. Then we have our source X, source Y, so where we want to start copying from, how wide an area we want to copy, and then we have a destination where we want to see it and how big that thing we want to now draw is on screen, because we don't have to. So we could copy a small thing and then redraw it bigger, and it would look all chunky and pixelated. But you couldn't. It would be fine with that. So we could double its size. So it's the image file, source X, source Y. Then this is kind of the width and height of the source we're copying from, the X and Y we want to draw it, and then the width and height we want to see it. The advantage of doing this, of course, is that we're only having to load a single graphic file instead of 23 files. So we're loading fewer files. The file's bigger, but it's actually a smaller hit on our memory because it's 2,000 bytes versus 23,000 bytes of information because of minimum file size limitations. So when we look at this, we just have to update where are we doing it, because if we think about it in the sprite sheet, we have to specify I'm loading the first image. That means I'm copied from 0, 0, then I go over 32, down 32, copy that square. The next time I want to start at 32 and go over to 64. The next time I want to start at 64 and go over to 96. So I keep copying each kind of 32 by 32 pixel square as I move my mouse in a circle. So square. Try that. Move your mouse in a circle and say this word square and find out what happens inside your brain. You find weird misfunctionings occur. So I'm copying that information. So what I have to do is, because we are only loading all of our images from a single row, we don't have to change our source Y value, which starts out at 0. But our source X will be the first frame, current frame starts at 0, times it by the width, 32. The next frame, I want to start copying from 32 to 64. Well, when current frame is 1, 1 times 32 means I start at 32 and get to copy over. The next time, when current frame is 2, 2 times 32 is 64. So it just takes the little chunk that I'm looking at, like I'm moving a window and saying, I move my window and say, copy this. Move my window, copy that. Move my window, copy. Move my window, copy. Move my window, copy. And when I get to 23, I use the same method to reset. I can either use the 1-line or the 4-line method. My feelings don't get hurt either way, so you can use whichever method makes you happy, and then it loads. And if we watch this, and we will even add in the x plus plus, so we still have the moving eye of Sauron's polar cousin. And we will see it wanders across while it's blinking. And that is really all there is to using sprite animation. Now, if you want to do a full spreadsheet where you have rows and columns, there's 2 more lines of programming that you would have to put into it, but I figure for today we don't need to go there. It's easier just to do a single line because it keeps it a little bit cleaner. Otherwise, our SY would be changing as well, and we'd have to use a slightly different formula for calculating that.